So we will start in about a couple of minutes, so maybe you can take your seats everywhere. Thank you. Excellent. So I think we can start. Good morning, everyone, and welcome to our event on how can the EU develop a viable recycle chain for rare earths. My name is Vasilos Rizos. In case you don't know me, I'm head of sustainable resources and circular economy here at CEPS. And just a couple of words to introduce the scene. I think during the past year, we have seen some major changes in the global geopolitical environment, and securing access to raw materials has really become the key priority for many major economies around the world, especially for resource-poor countries. And of course, at the European level, you probably know that there has been a conscious effort to revive the policy framework on raw materials. And the European Commission published in March a proposal for a Raw Material Act that includes a number of actions that aim to create sustainable supply of critical raw materials for the European Union. Now, the proposal, of course, identifies a group of so-called strategic raw materials, which are strategically important. I use here the words of the Raw Material Act for green digital space and defense applications. And rare earth elements for magnets are among these key materials identified in the list of strategic raw materials, and are important for a number of applications, including wind turbines, electric vehicles, electric e-bikes, white goods, and consumer electronics, just to name a few. Now, while there are a lot of discussions in Brussels, and not only on the raw material agenda, and probably you've noticed there have been several events and occasions to discuss about raw materials, there is also action happening on the ground. There are a lot of demonstration projects and initiatives that are trying to develop solutions that can reach the market at some stage. And one of them, of course, is INSPIRES, an EIT raw materials project that is co-funded by the European Union. And INSPIRES, as we will also hear later, aims to develop a closed-loop recycle chain for rare earth permanent magnets in Europe, covering all steps of the value chain, as you will hear later. And basically, the purpose today is to take on some of the messages of the project, especially some of the challenges perhaps we identified as well, and bring them in a policy context, and have a discussion about really how we can practically scale up recycling process for rare earth magnets in Europe. How can we bring these solutions, of course, to the market at scale, and to what extent, of course, the Critical Raw Materials Act will be an enabler, what are the gaps it's going to fill, and maybe what are the suggestions, on future action. And to do so, we have a panel today comprised of speakers from research academia, but also from the industry and policy. And basically, just to give you a couple of words how we're going to go on today. First, we will have a short introduction by the project coordinator of INSPIRES. You will have also opportunity to ask a couple of clarification questions about, maybe what happens next. This is what people ask very often. And then we will move on to the panel discussion. Be aware that the event is going to be recorded, so if you need later to go back to any of the messages, it will be made available on YouTube. And we're looking forward also later to receive your inputs and questions. I think it's a good opportunity to have these speakers from the panel just before the summer break and try to take on some of the messages we hear in town recently. Now, with no further delay, I would like to invite Adrian Chieseda Michelena, I hope I pronounced it correctly, from the Spanish National Research Council, who is also the Inspires project coordinator, so to, let's say, navigate us through the main lessons of Inspires. Adrian, yeah.
Thank you, Vasileos. Good morning, everyone. So I will wait for my presentation maybe to pop up first, but the idea is to, in order to frame the discussion that will start in a few minutes here, I wanted to tell you a little bit what we're doing in the Inspires project and how we are developing a recycling chain for recycling and recovering rare earth permanent magnets from home appliances is the extraction place that we've used for this. So I wanted to start with a brief introduction, of course. What is a magnet? A magnet is a material that can create spontaneously a magnetic field. And because of this very particular property, we have magnets everywhere in our daily lives. We have them in motors, in generators, we have them in all of our devices, in home appliances. It is actually estimated that each of us owns roughly around 200 magnets, unknowingly in many cases. Magnets allow us to transform mechanical energy into electrical energy and vice versa in generators and motors. And this is due to what we call the induction law. For this reason, magnets are key components in wind turbines and in the motors of electric cars. So key materials for our energy transition towards a more sustainable future. The best magnets in terms of performance that we have in the world are made with rare earths. You may remember from your high school days, the periodic table, the bottom two lines, these are called rare earth elements. And in particular, this little guy here called neodymium is a key element of the composition of the best magnet in the world, neodymium iron boron. Due to the increased demand that is expected for wind turbines and electric cars, the demand for neodymium iron boron is expected to increase quite rapidly in the next few years. The problem we have is that, I think the presentation went to a mode. Yes. So the problem we have is that rare earths are critical raw materials. And this is mainly because of two reasons. First of all, they're associated with supply risks and price volatility problems that are fueled by geopolitical tensions. China, a single country, controls most of the production and the price at all stages of the magnet fabrication, from the mining of the rare earths to the fabrication of the permanent magnets themselves. In this situation, Europe is particularly vulnerable as we import 98% of our rare earth magnets from China alone. The second problem is of environmental nature. The extraction, but actually even more so the separation of rare earths, is a very contaminant issue and process, sorry, specifically for the water surrounding the places and the locations where it's been mined and separated. The situation is so worse that China has started outsourcing the mining of rare earths to Myanmar. And this is in the northern mountains of Myanmar, a region that is controlled by militias right now. And not only are we having issues with deforestation and water pollution in these beautiful mountains, but also this recent report from the NGO Global Witness was pointing at possible human rights violations and illegal mining going on in this area. So in this framework, the question is, of course, how can we reduce, from a European perspective, our dependency on rare earths? The solution to this issue is, of course, multifaceted. We need to develop new supply chains at the European level. We need to develop new magnets that could substitute rare earth magnets, at least in some of the applications where you can find them. The problem is that this solution, being realistic, it still will take a few years from now. A perhaps faster solution is to start developing rare earth-free devices. And you may have seen in the news that both BMW and Tesla are announcing that their motors for their electric cars will not contain rare earth magnets. A fourth solution is to try to enhance the recycling rate of neodymium iron boron that is already within European borders. And it's exactly in this solution that the Inspires project is working on. The main goal of the project is to develop a recycling chain in Europe for the recovery and reuse of neodymium iron boron permanent magnets from home appliances. One of the main strengths of our 11 partner consortium is that we cover the whole value chain from the waste management, the extraction of the magnets, production of the magnets, and then integration into the devices. In this sense, the project can be divided in 4 main stages or steps. In the first step, we recover the magnets. By sorting out home appliances, we dismantle them and we extract the magnets out of them. These recovered magnets then go to the second step, recycling. We place the magnets under a hydrogen atmosphere, and the decrypitation process turns it back into a powder. This recycled powder is then sent to a magnet manufacturer that fabricates new magnets out of the recycled powder. And these new recycled magnets are being integrated in a motor for a washing machine, so that at the end of the project, we will present the first washing machine that is entirely made out of recycled magnets. So with 1 year left in the project, I wanted to tell you a little bit about the lessons that we have learned so far and the main challenges that we have encountered. Many of them are related to the first step, the recovery of the magnets. We are finding very different magnets in each of the home appliances that we open. Different magnets in terms of their compositions. We also find ferrites many times, their size, their shape, the coating that they have. And they're also very difficult to extract in many cases. For this reason, we are developing a database of which magnet we're finding in each of the home appliances that we're opening up. We're doing this by brand and model of the home appliance, and we believe this database could be of great use in the future for Europe. What we are learning is that neodymium iron boron recovery is labor intensive and it's expensive. It's actually the most expensive part of the process. It's also, our findings are hinting at the importance of labeling and marking. When you open up a home appliances or whatever device, it's very difficult to know what's inside, what magnets, where they are, how to extract them. And labeling and marking will be very important, as will be designed for recycling. As I was saying, it's very difficult to extract them in many cases. Eco-design rules are needed in this direction. Related to steps 2 to 4, so the recycling itself and then production of recycled permanent magnets and integration, the main challenge that we have is, of course, that we are always in a competition with the price and performance of the virgin powders and magnets that are coming from China. We need to be competitive in this sense. There are uncertainties related mainly with the rare earth price. Right now, China is dropping the price quite dramatically of neodymium, praseodymium metal price. And this is, of course, a problem for the business cases that we're trying to develop in Europe to counteract this. We're also finding problems with the skepticism related to the performance of these recycled magnets that we hope to address in the very near future. And we're also finding that the most efficient way to go about this is not a single recycling chain to be developed in Europe, but rather many local, smaller supply chains at regional level almost would be the most efficient way to do this. So having said this and having presented the challenges, we still believe that Inspires will be presented at the end of its life as a successful test case. We believe we will be able to supply next year very competitive neodymium iron boron recycled magnets in terms of both price and performance. We will provide the first commercial washing machine made entirely out of recycled magnets. And we hope that the project serves as a good example of, in this case, a national. Many of the companies in the consortium are located in Slovenia. A national example of a recycling chain that goes from waste managers to home appliances producers for rare earth magnets that could be replicated in different places in Europe. And with this, I thank you very much for your attention.
Thank you, Adrian, for giving us a good overview of the lessons learned from Inspires. So I'm wondering if there is any question for clarification or something that wasn't clear, or any question you have for Adrian and for the project. Yeah.
Okay. Yes, hello, my name is Capucine. I'm just studying critical rare of metals. And I was wondering if in your database, in trying to understand what the magnets were composed of and used for, the industries could be of any help, and if there were existing database that could help you.
There's no database right now. They are being developed in other projects also that are running right now, European projects. So we're just trying to fill it up with data, and it's a little bit unclear at this stage how it will be used or how it will be made available. probably open to everyone, but we will see. And the idea, yes, to upload it with all the information that we're gathering now. The issue that we have with these type of databases that we're always looking into the past when you recycle, right? So you're dismantling home appliances that were made maybe 5, 10, 15 years ago. So we get a snapshot of what was going on 10 years ago, but so these will need to be updated constantly. Yeah.
But yeah, but related to the data, Adriana, I think one thing that we noticed in the project is also the discrepancy sometimes between data that exists in the literature, and I'm referring to the rate of how many products out in the market include magnets, and what is the reality, which we found out in practice by dismantling devices. So I'm wondering if maybe you can explain a little bit this further. I think it will be interesting for the people. And also, what do you think would be the way forward to address this challenge with a discrepancy between the data that exists sometimes in literature or in academic publications and the reality of what we find when we open, let's say, a washing machine collected in Slovenia?
Yes, so in many cases, we're finding ferrite magnets inside these home appliances. The reason for this is that ferrite magnets, even if they have worse performance, they're way cheaper, sometimes a factor 10 cheaper. So even in the high-end home appliances, many times we find ferrites there. And this is not what was expected when we started the project, and not what's expected when you dismantle most of the home appliances. I think the way forward is what we were discussing. We need to upload this database and make sure that we understand what's going on in each of the home appliances, but also the importance in the future of these, probably, and maybe this will be discussed later, these digital passports for each of the application or end users, where you know exactly what magnets and what critical raw materials you have inside, so that it's easier to identify them and then extract them.
Okay. Thank you so much for the presentation. I'm Fatima from SAM group in Leuven University. I was just wondering whether using the recycled magnet has the same performance as the fresh one. And my second question is that whether you took into account the cost-benefit analysis, because if we change the process to the recycle or circular one, it may bring us extra costs. And I was wondering that did you took into account that point?
Yes.
Thank you.
Thank you for your questions. So related to the performance, excuse me for getting a bit technical here for a minute, but magnets have two main properties that are important for the application. One is the remanence. This is the magnetic field that they're able to create. And the other one is the coercivity, which is how easily they are to demagnetize, how robust is the magnet themselves. So we're finding very, very competitive properties in terms of the magnetic field that it can create in terms of these remanence, and we need to improve a little bit the coercivity. However, for many of the applications of the magnet, coercivity is not that important. So it's very good news that we have a good remanence there, and the magnets are competitive in that direction. With respect to the price, as I was saying, or the cost analysis, the main bottleneck right now is the recovery of the magnets. That's the expensive part of the process, and where we would need, in our opinion, financial support and financial incentives to try to compete with the price coming from China. The price of the magnet itself? No, it will be the same price. Yeah.
Hi, my name is Enrique Visser. I work for the Century and we investigate, amongst others, conflict minerals. So in line with the question about cost-benefit analysis, I was wondering if you think it's an option to focus on the impact on the ground and actually see that, well, there's an EU ban coming for forced and child labor products, for example. We see that a lot in Myanmar. So that could be an interesting PR way to balance out the maybe higher prices of these kind of magnets.
Yes, that's a very good point, and we fully agree. This is not only about price. This is a life cycle assessment that we're doing in the project as well. Should take care of all these aspects and how we're benefiting not only from an economic and industrial point of view for Europe, but also social. Yeah, very important point. Yeah, thanks.
You have a question?
Hello, my name is Alice, and I work for Bolt. And it's more of a personal interest. That's why I'm here. And I was particularly interested by when you said that I think consumers are pretty skeptical about if they buy a washing machine that it's made by recycled magnets, if it will be still same, in the same effectiveness as the new one. So I was wondering, do you already have partnerships with the industry, so with the retailers or with the producers of these home appliances? Because if you with this project actually prove the the benefits of recovering these magnets, as you said, for the environment and other many reasons. Do you already have some partnerships, and are you planning to do so? Because I think that the industry might want to participate in that, I hope, at least.
Yes, thank you for your question. So already inside the consortium of the project, we have a partner that fabricates the motors with the magnets, and these motors are then integrated in the washing machine. Then the fabrication of the washing machine is taken care by a different company. So where we're seeing this skepticism is not at user level or consumer level. It's more within the community, the research community, and also some of the motor manufacturers that would like to make sure that if they put in recycled magnets, they will get the same performance for their motors. So we know in the case of our consortium that the Domel is the name of the company in Slovenia. They're happy with the properties of the magnets, the recycled magnets that we're supplying. And in this sense, we hope to be an example as well of these magnets work, and the devices, the motors and generators that you can make out of them do have the same performance, and it's no issue there.
Excellent. I think we can move on to the next phase of the meeting. Thanks a lot, Adrian, and we will have plenty of opportunity to discuss about Inspires also afterwards. Now, just excuse us for a couple of minutes to arrange the panel. So if we can ask the panelists to just take their seats on the panel. Thank you. No, not really. Go in order according to the agenda. Excellent. Now I think it's time to move to the panel discussion, and we're going to go in order according to the agenda. So first of all, we will start with Milan Grochol, who is a policy officer at the DG Grow of the European Commission, and Milan has over 20 years of experience in the European Commission working in materials, but he also has a background to understand a lot of the technical complexities. He has a degree in materials engineering, but also in material economics, I understand. You can explain about this a bit later. So he will kick off the discussion by presenting, of course, what is really the key elements in the proposal, in the Raw Material Act proposal that came out recently. Then we will continue with having two academic experts from the Inspires project. First, we will start with Carlo Bucart, who is scientific director at the Institute for Precious and Technology Metals at Fordham University. Now, Carlo has a very long academic record in the field, but he's also engaged in trying to bring these recycling solutions from the demonstration stage to the market, basically. So he will be able to share a lot of experience from Inspires, but also other projects he's involved at the moment. Then we will move on to Spomenka Kobe from the Josef Stefan Institute. Now, Spomenka has initiated rare earth magnet research activities in Slovenia, and she will be able to really she's, I think, very well equipped to explain what has happened in Slovenia and what are really the key lessons we can take over at the European Union level. And of course, not the least to say, he has been involved, coordinated many European projects, and he also has a long record of publications in the field. And we will conclude the panel with a representative from the industry, Jürgen Miller, who is Director Product Support and Release Management at SEW Eurodrive, a large EU motor manufacturer. So Jürgen has an engineer background and a long experience within the company, and he will be able to provide an industry perspective and really explain how he thinks that recycling of rare earth magnets can happen at scale in Europe. Now, all of the speakers will have 7 to 10 minutes to provide a short introductory contribution, and that should thankfully give us a lot of time afterwards for a discussion and take over your question. So we will start with Milan. So Milan, thanks for your time today and for coming to SEPS for this event. So there is really, I think, an ambitious proposal on the table that has generated a lot of discussions. So I'm not sure if you can say us what will happen afterwards. That's also up to a discussion at the moment, but maybe you can tell us what is the key elements in the proposal at the moment. Yeah.
Vasilis, thank you very much. Does it work? Yeah, it's okay. It's working. Super. So thank you very much for kind introduction and invitation to this event. Rare earths and magnets is my favorite topic actually from all critical raw materials, which I work on already for almost 20 years in the Commission. And actually, I'm a mineral processing engineer and mineral economics PhD in by training. So all this is really very close to my heart. After a very long time, it's over almost 15 years policy development, we are at the moment where we have the first legal act coming from the Commission side to support raw materials area. This is really something exceptional. Only similar attempts have been done in 70s. So this was a really long time ago. So now it's the first time. I will not kill you by PowerPoint. I have just 4 points to mention. Short overview of the Critical Raw Materials Act, which we published, and the points where the rare earths magnets play important role. Second, I highlighted 2 articles which are directly relevant to what you were saying now. Actually, there are more, but that's good news for recyclers, magnet producers, and of course manufacturers, the users of magnets. Another slide, not to forget, we are also in charge in the unit for programming around 100 million euro plus for raw materials, and for next year we have a very interesting call for innovation hubs for rare earths magnets. And the last one would be invitation to one event. So next slide, please, if I can. Ah, very good. Okay, super. Yeah. Okay. Let's see if it works. Where is the computer? Which direction? Okay. This one. Does it work? Oh la la. Okay, it's a little bit packed. So, what's new in the Raw Materials Act? There are plenty of different things. First thing which we did is the analytics behind. So the graphs which you see there are actually related to the permanent magnets in electric drives, in motors. So first, the red bar at the bottom you see, it's China across everything. Okay, so that's the analytics which we also confirmed ourselves with colleagues from Joint Research Center. We also did the foresight, and you see the bars on the right side. We will need a lot of different elements, and of course neodymium dysprosium for electric drives, for traction motors, will also grow. It's a very complex graph. I will not spend time on that unless you really want me. It shows to us that there is a problem, and there will be even bigger problem already now. The table in the middle is the result of hundreds of pages and thousands, actually, tens of thousands of data points, is the list of critical raw materials and strategic raw materials. This is novelty in the Act. We have the list of 16 strategic raw materials which are important for the future strategic technologies, or for strategic technologies for the digital and green transition and space and defense. And we have the list of critical raw materials. The strategic ones become automatically critical. Altogether 32 critical raw materials, which are also currently very important for the EU economy, and we see supply risks as a big concern for them. So rare earths were always scoring top in all calculations, in all considerations, and especially in relations to magnets. 10 years ago, it was a little bit different story. It was mostly rare earths for lighting. Now it's rare earths for magnets. So that's a little bit the change of focus. So that's the analytics which has been done, and it has been relatively regular, this time a bit upgraded, and it came to, it helped us to confirm the future orientations and also the logic of this Critical Raw Materials Act. So for the first time we put something like benchmarks. These are not targets, these are aspirational benchmarks. We never had that in the raw materials area. It's usually in the big files like energy, climate. It's for the first time where we see benchmarks for domestic production covering our capacity or our demand. So for extraction, we propose 10%, for processing 40%, for recycling 15%, and we would not like to be dependent on one single country processing capacity more than 65%. This reflects some very special materials which are very concentrated. So these are for the first time benchmarks in our area of raw materials. And this links to the objectives which we have in the Critical Raw Materials Act. We would like to strengthen all stages of the value chain in the EU. There we would have strategic projects that has been inspired by the energy regulations of the energy infrastructures regulation 10E from I think 2013, helping strategic projects to get faster permitting, better access to funding, even though in the act directly there is no directly connected funding. It refers to many different funds, and we are waiting also for the announcement of the sovereignty fund, which should come very soon. Then we would like to diversify the supply, better diversify the supply of the critical and strategic raw materials. At the moment, very high concentration. China, as you mentioned, for us is very worrying, and it's not only at the stage of extraction, but actually in the later stages until magnets. I must say that it's quite unique here. Rare earths or the magnets would have their own provisions in the Critical Raw Materials Act. I will come to at least two directly focused articles on that later, but it's the rare earths and magnets play a really special role in the Critical Raw Materials Act. We would also like to improve our monitoring, and we would like to we propose some provisions also for mitigating the risk, like stockpiling or preparedness of the companies for any crisis. And last but not least, and that's where actually the magnets are mentioned mostly, is the circularity and sustainability part. We mentioned I will mention the two articles there, but plus we have certification schemes not only for magnets but also for other critical raw materials. That's what we would like to see happening. So there are two articles. One, this article is probably making recyclers very happy, and we want to label and also the user or the producers of magnets, because they would know how much of what would come from the recyclers. We would like to label different types of permanent magnets, and just to make sure that we don't miss anything, we would label all of them which are basically used. So everything from ferrites to neodymium magnets, samarium cobalt, aluminum nickel cobalt magnets as well. So very important measure. Recyclers need to know what is inside. At least that's what we were told. This goes very well, right in the direction which you mentioned, Vasilis, and actually also Adrian, that we would not like to duplicate the digital product passports already, which would exist under the eco design regulation in the future. But that's something which where we would like to see harmonization. But we would like to get the information how much of what we will have in the magnets. Confidentiality should be ensured, so we need to be sure that the public will there will be no leakage of trade secrets to the public, because that could endanger the European industry. Next article is the is making happy the users of magnets, so that's automotive manufacturers or wind turbine manufacturers. This is for them to choose the magnets which are more sustainable. They are coming from the recycling, and they would see the properties. We plan also delegated acts out of that. So in the first step, we would like just to improve the transparency without any thresholds of any requirements for recycled content. But then after 2030, we may come with the delegated act to propose some requirements, some targets for that. And this is thing which I mentioned shortly, is the major call. It's around 30 million euro. We would like to have a network of all involved researchers, industries, along the value chain of rare earth magnets. Plus, we would like to see demonstrators coming out of this network directly. So this is the action which has been launched based on the action plan produced by the European Raw Materials Alliance. Probably some of you remember the times when Roland Gauss was coordinating this initiative around 2020, and this is direct outcome of the report which has been published. So we have issues along the value chain, especially in metal making. We would like to fill it, and we would like all the players to come, not necessarily into one project. Could be one, could be more projects. And the last thing to mention here is to invite you, if you would like to see what's going on, what's new according to in the critical raw materials arc development. We are not starting. We are developing the agenda for the raw materials week now. I'm organizing that, and we will program it according to the chapters of the Critical Raw Materials Act. So, and we hope that magnets will also play a role there. So, thank you very much, and you are kindly invited.
Very good. Yeah. Thank you, Milan. This is very interesting, and I would be very curious to hear also what Carlos Spomenka think about these direct provisions in the Raw Material Act. Certainly, that there will be changes. There are changes on the horizon. Just a quick follow-up question from me is that, of course, through the project, but also what many experts have told us during the period where we are in the project is that for batteries, there's a very ambitious piece of regulation that comes out from a European Union level. Perhaps the most ambitious, people call it, piece of law run for a technology application. And people were always asking, do we need something similar for magnets? Do we need the same level of ambition? And of course, now you have some specific provisions in the Raw Material Act, but how do you see this evolving in the future? Do you see like having different provisions for magnets in different pieces of regulation? Or you think at some point this could also follow the path of the battery regulation, having something more concentrated in one piece of law? If you have any thoughts on it or ideas, maybe it's too preliminary, but question that many researchers have as well. Yeah.
No, actually, it's not the act which has been the biggest milestone in magnets. It has been really the 2020 action plan of the Commission, and also collaboration with ERMA. So since that time, we started to work on several different legislations in waste shipment, in actually, we were trying to cover mostly wind turbines and the automotive, the magnets for the automotive. And actually, what is going on at the moment, and there are references to the regulations related to the end-of-life vehicles, and actually there is an update of the regulation on the end-of-life now. My colleagues are working on that. In this act, we have these two provisions which are directly linked, but we are waiting, we are expecting that provisions for magnets will be placed and updated in the future in any most relevant piece of legislation. Okay, so at the moment there are references also to non-existing legislations which are going in parallel in the proposal, but we try to work on all fronts to catch all the magnets which are necessary. Here we target, for example, magnets over 200 for the recycled content over 200 grams. Okay, so that's in product. So that's something which is a limit. So not everywhere, but we will try to target the magnets across the different legislations, and we started already before 2000, but 2020, sorry, 2020 was really the milestone where we started to go through all the legislations, and we continue, and this act is just strengthening this.
Perfect. Many thanks, and we can come back to some of these issues later. So now maybe we can go in order according to the agenda. So we can start with Carlo. Carlo, there have been some also quick direct provisions in by Milan about what's happening in the future for magnets. So how do you see these policy developments, and also practically, from your point of view, how can we bring solutions like the ones we do in Inspires in the market, basically? Yeah.
Now you can hear me. Yeah, okay. Well, thank you very much for the invitation in the first place. And a quick question, I see the policy engagement of the European Union very positive because there are a lot of frame boundary conditions that have to be defined, which help for recycling, which bring the contents up. I'm a bit impatient. I've always been an impatient person, so it could go faster, but we see that it's heading definitely in the right direction. I'm a material scientist, so I will bother you with 2 slides to set a little bit more the scene of what we're currently struggling about with in making recycling efficient. And first of all, what I put down here is the value chain of making magnets. And that's actually very long. And a lot of people are talking about we are having a rare earth crisis. And that's not necessarily true, because we have more a magnets crisis. Because when we have the rare earths, still we don't have a magnet. So first of all, you have to take the rare earths out of the ground. They are not rare, but they're finely dispersed, and it takes a lot of effort and a lot of material. It's like with gold mining. You have to break a lot of rocks before you get a little bit of rare earths out. Unfortunately, there are all 17 of them. Unfortunately, they are always coming with radioactive elements which have to be separated, like uranium, like thorium. And there are only a couple of them which are really of industrial use, which is neodymium, praseodymium, and terbium, and dysprosium for the magnets. So you have to separate this. And the solvent extraction is another very complicated process which involves a lot of chemicals and could, if done as it is today, lead to a lot of environmental pollution and in the water. Then the second, once you've got a rare earth oxide, you have to make a metal out of it. That's electrorefining. That costs a lot of energy. Is also causing greenhouse gas potential. And then once you have the neodymium or the dysprosium and so on, you have to alloy it with iron, with boron. Again, an energy-intensive process, and then you can produce your magnet. And if you're looking into recycling, there are 2 ways of doing it. There's one which is a conventional, what we call the long loop or magnet to rare earths. Here you take the magnet, and you, by solvent extraction, which is very similar to what you do with the rocks, you extract the neodymium oxide. You reduce it again, go into the alloy, and so from the energy point of view, a lot of energy again needed, a lot of chemicals needed. And there's a second one that we are focusing on, which is the short loop, which is also called magnet to magnet. And in that case, we take this alloy that we have from the magnet, make a powder out of it, and directly make the magnet out of it. And as a little illustration, just imagine your magnet being very small individual magnets, like the orange things you see here. And they're glued together with a neodymium-rich phase, which is the rare earth-rich phase, which is magnetically insulating it and just holding it together. And we expose this magnet to hydrogen. And what's happening is the hydrogen is introducing the structure, is forming a hydride which is bigger in volume. And it's like in winter when the ice or the water freezes in the road, you get a crack. So you really crack the material apart. And you do this at room temperature at 1 bar. And so this is much more energy efficient. And if you look on the environmental impact, and that's something very complicated. I come to that in a bit, because the most energy intensive thing now in recycling a magnet is extracting it from the component. So I've shown it here for a speaker magnet, loudspeaker magnet, and you see the greenhouse gas emissions 65% less, toxicity 60 to 70% less, energy use 58% less, because we still have to sinter the magnet, so energy is going in here, yes, which is more expensive in Europe, by the way, than in a lot of other countries, so we have to discuss about this. And the water use, we need some coolants, but it's 70% less. So from that point of view, a very very environmentally friendly process. And that's a kind of the advert part. So this is very simple once the magnet is on the table. Then we also have a very cheap process. But the real issue is how to extract the magnet. And you already sit here focusing on wind turbines, on traction motors. That's a good idea, because there you have a lot of material at the same place. In a wind turbine, 650 kilograms per megawatt, which adds up in the large offshores to more than 10 tons in the newest ones. And in a car, it could be between 2 and 5 kilograms. But then again, you have to disassemble the rotor, you have to disassemble the traction motor. And this is a very specific business, because if you think of it, you have to open the motor, you have to separate the stator from the rotor, then you have to extract the magnet, and this has to be cheap. And here there are two things. One, this market is not developed, and it's not developed yet because there's not a lot of material on the market. I mean, luckily these electric cars, well, I'm driving one, I'm a strong supporter of it. I was couple of months ago on a panel discussion where we had 80% of environmental or climate change deniers. There was a different situation, so I'm pointing out, yes, I'm definitely on that side. But these cars, they run for another 10, 15 years before they come back. So we have to develop now an infrastructure, which is one thing we are trying to doing in one of our European projects, and hopefully now with a national spin-off, to make an automated disassembly, because in the end, it has to be competitive, because if a recycled material is twice or 3 times as expensive just because of the extraction, it will not be a business case. And then it can only be a business case with a kind of a political support, which we think currently is necessary, but on the long run, I think it should be competitive also on an industrial level. So that's one thing. And if you look at the rotor, for example, of a wind turbine, here the magnets are very strong. So here the demagnetization is a big issue, because if they jump together, you probably know the small magnets, you can get a little blood clot, but if the large ones are jumping together and your hand would be in between, the hand is not there anymore. So there is a lot of safety things that have to be looked at, and also this has to be developed. And so in a project we're looking forward, because we say we tick the box here with the recycling. When it comes to quality, of course there's a second issue in, and if the magnet is very clean, I agree completely with Adrian, then we can make the same quality as we have in the end-of-life magnet. However, the end-of-life magnet has a little bit more oxygen in, so this oxygen, it comes to that remnants is slightly lower if we don't remove it. So that another one of the research activities we have is to remove that oxides, to blend it with a little bit of either recycled over the long loop or virgin neodymium to get up to the same remnants. And the second thing, what we're looking into, and that's something which is really a key to the whole thing, is design for recycling. Because Adrian also mentioned, we see now the things that have been produced 10, 5 years ago, in the case of flat screens, sometimes 2 years ago, in the case of industrial motors, probably 30 years ago. Yeah? And so the knowledge we have on how the recycling is working now, and what kind of coatings, for example, are easy to separate from the magnet, which ones are contaminating the thing from the carbon side of view, that's very important. And so we are also developing a design for recycling guide. And what we're also working on is this database, which is Inspires, but there's also one in SOSMEC Pro, which is a project I'm coordinating, and Resilience, which is another one I'm coordinating, that these databases come together, and out of the database, we also developed in a project with Spomenka, where she was coordinating, which was called MaxLycle, a DMC code, which goes on the outside of the component that you easily can see, of course, covered with blockchain, because no manufacturer wants to see what magnet is inside, because not only he sees, but everybody else. So this will be encrypted, encoded, but it helps much more to detect what kind of magnet is in, because today we're struggling if, for example, flat screen TVs are coming back to a recycler. They are the thick ones, which are about 5 years old, 6 years old. They have ferrites in. The smaller ones, the thinner ones, have neodymium iron boron in, and we have to separate it. And today we're developing sensors and cameras to do so, but it would be much easier if a DMC code on the outside is doing that automatically. And that, we also talk to recyclers, is much more feasible than a product pass. They say the product pass is good for cars, it's good for, you know, components that come in large quantities. But if you have the mixed scrap, or very diverse scrap, the reality on a scrapyard where the recyclers are separating is that the stuff comes in and it has easily to be detected. And here we think that this kind of DMC codes developed are a key. So to sum it up, it's a very multifaceted business to get it running. We could say from an academic side, it's working, it's perfect, that is this slide. But if you then go nearer to industrialization, there are a couple of issues that have to be addressed. And we're very happy that we are supported by the European Union here, because all these projects get European funding, and without that, and a long time of funding already, it would not be possible to do this, because coming to the OEMs, 3 years ago, I was talking to a very large car manufacturer from Germany, and we were talking about recycling. And, well, that's now our original quote, well, not word by word, not verbatim, but by the sense of it, he said, well, we're not interested in recycling, and especially we're not interested in you telling somebody that the magnets are dirty and not environmentally friendly, because we just had a diesel scandal, and now per definition, the electric cars, they are clean. And the magnets are a commodity from China, they're cheap, so don't overthink these things. And yeah. Same company last year in Brussels, they came to me and said, we have to talk about magnets recycling, because now things happen, you know, the Ukraine crisis, and in Germany we see, well, Russian gas is suddenly not reliable anymore. And also, you know, Taiwan conflict, a lot of discussions, disrupting supply chains. And then he said, we have to talk about recycling. And I said to him, well, talk to your purchasing guy. Per definition, this is a commodity and you don't want to talk about it. And then he said to me, well, I'm from the purchasing and our sustainability is part of the purchasing. So things changed very much here. And that's a good thing, because now also in the project, we always covered the whole value chain back to the tier one, producing the magnet, but never had the OEMs in. And now we have a national project where one of the major OEMs is a driving force in saying we have to develop this process and we have to get it commercially viable. And so overall, heading in the right direction. And I see you want to stop me, which is a good thing, because I could talk for hours, and I would.
Thank you, Carlo. That was very positive. Just a quick follow-up question. In your previous slide, I think it will be useful for the audience to explain there are two major technologies, let's say, and it will be good to know your views about how do you see this landscape of technologies evolving in the future, because there are many different magnet applications we heard earlier. So can we have actually market for both of these processes? How do you think like this evolving in the future?
Yeah, sorry, I should have mentioned that. Yes, definitely yes. I mean, we need a clever interaction between all of them. I mean, the short loop recycling, as I said, is environmentally friendly, but it's not working for all of the products. If the product is highly contaminated, if you have low quantities in, for example, then the hydrometallurgy is a much better route. And in the project that we have Resilience, we have with Carister, a French startup, which is doing hydrometallurgy. And we are also developing kind of key indicators, which value stream better goes into the short loop, which goes into the long loop recycling. So they are not well, they're competing a bit commercially later on, but they should interact, because the worst thing that could happen is fighting for the scrap magnets, and bringing the prices up of the scrap material just by, competing on that side. And the second thing, which is important, recycling is good, is necessary, but it will not solve our supply problem. Because very simple equation, we have 4 million electric cars on the road. Let's say in 10 years we recycle 100%, and we recycle all of it, and they last only 10 years, and we want to produce 40, and there's a big gap. So we have to combine this with preferably non-Chinese virgin material, and we can mix these things, and that's probably also an important thing to take home. I mean, if these quotas, when they're coming, let's say 5% of the magnets have to be recycled. There are two ways of doing it. You could have 5% of the magnets that are 100% recycled, or you could 100% of your magnets could have 5% of recycling material blended in and 95% of virgin material. And that's probably the much better way, because that helps us to get the yield up, because then, let's say, a bit dirty material, which has too high oxygen content or a bit too much carbon, can be diluted then and still give you the maximum performance. And that's the way we're really heading, not going magnet to magnet, means make a traction motor magnet out of a traction motor, but blend the material in and then have different qualities.
Very good. I think this is much clearer. Okay, now we can move to the next speaker, to Spomenka. And Spomenka, when it comes to rare earth permanent magnets, the spotlight is on Slovenia, of course, where there's a permanent magnet industry. And yeah, we're very eager to hear what are the messages that you have to convey from the Slovenian case, and what do you think can be done to replicate this approach in other member states as well. Yeah.
Thank you very much, Vasilios, for the introduction. Please let me first thank you for organizing this event, extremely important, and to give me the opportunity to wrap up part of the results which we already have in the project. Still, we are 1 year to go, as Adrian said, and but from the collecting of the scrap magnets, we can have some wrap up already. And you ask what lessons can be learned from the existing value chain, and I'm sure that the example which we have here in Inspires from Slovenia could be replicated to EU for sure. So I need to start with presenting two companies from the Inspires project, Surovina and Zeos. They are, I don't know the word, scrap managers or whatever companies who they collect the electronic devices and all kind of scrap which is needed to get magnets out, and they did a perfect job in collection, sorting, and dismantling. When we started with this project, the idea was to use the washing machines and dishwashers from the big company Gorenje in Slovenia. And we were quite disappointing to see that there were mainly ferrites in these white goods. So there were two reasons to change a bit the scope of the project. First of all, these ferrites in the white goods, and also there was a main motivation to advance the capabilities to extract magnets from all common home appliances, consumer electronic and other, already available in Europe, waste electronic and electronic equipment. And the data and steps presented are influenced, as we said, by regional specifics, but it is expected that the differences between European member states are minimal. The main difference could arise from non-European members, especially with countries and markets outside continental Europe. The planning process is the most important step in the neodymium iron boron magnet recycling process, especially We knew now everything, almost everything from the wind turbines and cars, but this is a new area. And the main reasons for this planning are discrepancy between the literature data, as we heard from Vasilios, and the practical disassembly. Then ever-changing composition of the market and consequently this electronic waste composition as well. Fluctuation in magnet and magnet coating elemental composition and the labor-intensive extraction. Maybe I'm repeating some things which you already heard, but does not matter. Eh? So the important criteria in collecting end-of-life magnets are as follows: easily collectible, recognizable, and accessible, safe to store and extract, sufficient and stable quantities, sufficient and stable quality, and synergistic value. The first objective is that the target components with stable sources and composition should be favored, of course, since this at least partly enables the economy of scale and eases the whole planning process. The second objective is usually to reclaim all materials that can be sold on a market, like electromotor, copper, iron. Here, an additional supplementary process of specialized extractions of neodymium iron-boron magnets from electromotor should be added, and this way the costs are reduced and gains are optimized. Based on the work done so far, it can be concluded that neodymium iron-boron magnets are most readily available in appliances constrained by size, battery-operated tools, high-performance electronics and electronic equipment, magnetic closures, fixtures, clips, latches, catches. The practical extraction of magnets should be done only in a suitable equipped facility with all legislatively required permissions, applicable standards, and carries out work with duly trained workers. The disassembly process should be done in environmentally sound manner with minimal negative effect on the environment and workers' health, of course, ideally using the best available technologies. What is going on now? Okay, sorry. So, as said before, we were disappointed in white goods, but there were some examples in more expensive washing machines that we found neodymium iron-boron magnets. They were inside the rotor of the main motor, which was easily accessible from the bottom side of the washing machine. But the magnets are glued and pressed in the rotor, so the extraction is harder. In tumble machines, the magnets are in the filter door closing mechanisms, easily to be removed. And in dishwashing machines, those magnets were found in the door locking mechanisms, also easily to be removed. What we found out was also that the battery-powered hand tools, they have neodymium iron-boron magnets, and here it was interesting that it was unrelated to their price aspect. So what we did was also the collection was hard disk drives, but we did not pay attention to this because we did not want to double the work which is already covered by SUSMAC Pro project, coordinated by Carla. The headphones were useless because the small magnet has 0.2 grams. It is embedded in plastic, which it's very hard to be removed, and if you burn it out, then you contaminate the magnet to such an extent that it cannot be used. What was good were flat TV screens, which are already commercially disassembled at Surovina, and they found roughly 10 to 30% of flat screen monitors with this neodymium iron-boron magnets, and which is important part of this is that within the existing system, the speakers ended up in the fraction metal. So now with this, it's very easy to collect the magnets separately, no extra costs in this case. The most promising source for neodymium iron-boron recycling are electric scooter motors. Although the quality of the magnet used in the motor is not the highest, but it is relatively easily to separately collect them and to extract the magnets. Less than 5 minutes is needed to disassemble one motor with average yield of 200 grams. We heard that this is the limit. So this is a good thing. And furthermore, end-of-life electric scooters are already available, and their quantities will grow aggressively for the foreseeable future. I will end up with this, what they prepared, our colleagues in Slovenia, tips for the future work. I will not go to the details, but they made a strategy for hard disassembly, fine disassembly, processing and shipping, and data analysis. And with this, I will finish this presentation, and I'm ready to answer the questions. I'm sorry, Vasilios, one more thing I wanted to say at the beginning. What I heard from you, Milan, it is so good that it is for people who work in rare earth magnets, time to live in. Because this is our golden era, maybe, started. Thank you.
Very good. Spomenka, now that in the future we will be having the right policy environment, as it seems, for magnets, a question that many people have is that how will the industrial landscape in Europe look like for permanent magnets? I mean, and from your perspective, do you think we will be having some specific industrial hubs in some countries? One of them could be Slovenia, for example, for magnets, or you see that there will be dispersed solutions in many member states? So, yeah, it could be both, of course, but yeah.
It could be both, but I agree with what Adrian said at the beginning. It should be in many member states, especially in cases where can be locally, covered, like in this region of Slovenia. I think it should go to every separate country. Okay, those countries who are interested, of course, but or maybe the big hubs. But you should think of the transport of the, I think it should be locally, at least from this experience which we have now.
Carlo, you're going to comment on this? Yeah.
Yes, I would like to add, we've spoken to a couple of recyclers, and indeed recycling is a very local business, because also if you look at production scrap, for example, at a motor manufacturer, if their production scrap, they want to have it off their premises. And so sometimes this is done on a daily basis. So let's say your recycler is 500 kilometers away. This is just not a business case anymore. So the scrap has to come to certain places where it's distributed. That's how it's working today. And we, for example, have a recycler in our region. He says, I'm not doing anything that's more than 30 miles away, because that doesn't make sense. So we have to have these regional hubs. Of course, they will be industry driven, because we have these industrial clusters. And so in one area, it may be more the home appliances. In one area, may be more the traction motors, whatever, also depending on the recycler. But also what Spomenka mentioned, the added value. Because a simple example, if you look at the traction motor, you have these electro sheets and you have the magnets. The electro sheets are currently 700 euros per ton. If they're contaminated by magnets, they're only half the price, 350. So there's a large benefit in extracting the magnets and separating from the electrode sheet, because that's making the business case better for the recycler on both ways. And that's something that's currently not in the equation. And so this local and very specialized business, I think, is a key for the recycling.
Okay, very good. Thank you, Carlos. So now we can move to our last panelist, Jürgen Miller. Jürgen, first of all, thank you for coming to Brussels for this event. I hope it is worthwhile. And, there are quite a lot of policy developments, as we heard, but from the perspective of a large European motor manufacturer, I mean, what do you think are the key challenges that perhaps you face in bringing these solutions to the market? And also, yeah, what do you think needs to change from a policy and market perspective, perhaps? Yeah.
Thank you very much for that introduction and for the invitation to this beautiful event, where I can learn a lot of things about magnets and about the projects. I'm an employee of a German manufacturer, and we are located in the south of Germany, where we have a lot of tooling machine producers, and we are manufacturing servo motors with permanent magnets. We are also manufacturing a large amount of geared asynchronous motors, and also electric and electronic devices to control these motors. We have three main reasons why we are very interested in these recycling projects. First of all, our demand for magnets is permanently increasing. It's the same with the wind generating and the electric vehicles, because automatization and digitalization is a major trend at the moment, and this leads to an increased demand on highly dynamic motors for these production machines, and we have a lot of customers in that area. The second thing is that SEW has developed a sustainability strategy about 10 years ago, and we started to realize the first product cycles with electric inverters. We made some good and some bad experience, but we learned a lot from these first projects, and then continued with the motors, and currently we are at that state that we expect a lot of material back. We have two things. First of all, we know that for motors, the product carbon footprint is generated by 90% during the operation phase at the end user application. So we are focusing on increasing the efficiency of the motors, and that means our new designs are highly efficient. And this year we released a new motor. It's a IE5 motor of highest efficiency, and we prepared everything to bring in and bring out the magnets to this motor very easily. And I have here a small iron plate of this rotor. You see this slot, and the magnets can insert it very easily, and we also can remove the magnets very easily. And our main homework is to get back the material, because we assemble the motors, and so we are able to easily dismantle the motors. And if we get back the motors, so we can provide the recycling facilities with perfect material, because we make the separation in our plants, and that's our plan. And it has another advantage, because if we design these magnets well, a part of the magnets can be reused without any recycling processes, and that's our main goal. We would like to reuse the magnets if they fulfill our requirements to the performance, and we made some first studies which are very successful, and we are optimistic that these used magnets can also be inserted in new products without decrease of the dynamic and of the technical properties. So this is the work we do with new motors at the moment, and it looks very good, because this motor already was awarded as product of the year of one of the automatization magazines in Germany, and we hope that we will bring it to the market in order to reduce the product carbon footprints through the high efficiency of this motor. The second thing is we have millions of motors in the field that are designed 15, 20 years ago, and the magnets are fixed with a special glue on the rotating shaft of this motor. And we also are very interested to get back this magnetic material from the rotor. So we worked with a big project during the last 2 years to find a method to remove the magnets from the rotors. And also this project is very promising, and we have a method to remove the magnets. We have some final investigations to perform, because we did that only with a handful of motors. So we have not a large number to have reliable data on these results, but we are very optimistic that we also can use these old motors for recycling. And the major problem that we have is how we get access to our end customers, because usually our motors are sold to OEMs, and the OEMs is providing the end user with his machine, with our motors, and we do not have direct access to these end customers. And we are still not a demolition company or a recycling company. So we are working on business models, and we are in contact with customers to clarify how we can get back the material, because we have the best facilities for dismantling, and we would like to very professionally generate the material for the recycling plants that hopefully will appear during the next years, because it's exactly what Professor Burkhardt said. We want not to have mixed garbage. We want pure magnetic material for his processes, and that's what we do. And we hope that we all together will find ways to increase and professionalize the recycling plants here in Europe, because it's a big task for all of us. Thank you very much.
No, this is excellent. Thank you, Jürgen. Maybe a quick follow-up question. You know, we, as a motor manufacturer, would you feel that, do you think there's a need for increase some kind of confidence in the market regarding the quality of recycled magnets, or for you you don't have such concerns? Because there's always the question about whether there's a need for a certification. That's also linked to what Adrian mentioned in the introduction about the perception that some people have about the quality of recycled magnets. Is this something that of concern to you, or maybe not? Yeah.
Yes, I think it's not a problem. It's a homework for us that we have to do, that we provide our customers with product that have the same qualities, unless there are new magnets in or used magnets in. And we have some experience with the asynchronous motors. For example, our Dutch colleagues, they offer a model that they remanufacture asynchronous motors, and they give 1 year more of warranty to these remanufactured products to create reliability in the products. And finally, the quality of the product and the running without problems will create the reliability. And that's our homework. We have to prepare everything that these products with reused magnets have the same quality and the same reliability as the new ones.
Excellent. Thank you very much. Now, I have a list of questions here I have prepared with my colleague Eduardo Righetti, who's sitting back there. But we want to take your questions and any kind of thoughts you have, question for any of the speakers to kick off the discussion. We are happy to take them on board.
Yes, hello. Good morning. I'm Maria Maggiore from Investigate Europe. It's a consortium of journalists. I have a question for Mr. Grohl. I thank you very much for this initiative, first of all. So I see this strong energy in starting this process of finally putting targets and finally have a legislation. I mean, we are talking with the market is very encouraging. At the same time, these targets seem all very ambitious for the very short time you put to yourself. 2030, it's less than 7 years. There are a lot of delegates acts which should be put in place. So how did you arrive there? It's just an average of different raw materials. Did you look at the demand forecast, or did you did you look at the available data on supply? And linked with that, because every serious target plans in the Commission always goes with a financial plan. Here, there is no fresh money at the beginning, but you have plans. If you can tell us a little bit more about this foreigner sovereign fund, how much money do you hope to collect in the market? It's working very well. And if you think other kind of funds should be used, view the very short time, like regional funds or post-COVID recovery funds. I would have many other questions, but I see the other question is for Mr. Carlo Burchard. Sorry for the pronunciation. Thank you very much also for your introduction. Very interesting. It's interesting, this other option, magnet to magnet. I didn't understand very well the technical part. Perhaps we can take a few minutes after. But you said the main good reason to go toward that is the economy of energy using hydrogen. But hydrogen needs to be produced. So as the majority of the market comes from fossil energy to produce hydrogen, how do you plan to use hydrogen? Thank you.
We can take one more question if anyone wants to take the floor now. Okay, yeah.
Yes, hello, I'm Barbara. I'm a sinologist. I have an interest in China, international relations, and its complicated relationship with Europe. So I would like to ask Mr. Grohol, so what I understand from today's presentation is that this recycling process has many challenges, and this has to do with the various type of raw materials and also the new products and their use. So it can be probably washing machine, or it can be a fighter jet. So this process requires know-how, expertise, technology, and infrastructure. What countries do you think, EU member countries, what countries do you think in the near future have the possibility to involve into hubs, recycling hubs for rare earths? Yes, is it going to be countries that we have some rare earth production, or others who have developed infrastructure for products that incorporate rare earths, such as vehicle batteries? Thank you.
Okay, Milan, I'm sure you were expecting a question about the targets and the sovereignty fund. And if you have, of course, anything else to add regarding the products, but that's also something that Spomeko and Carlo can comment. And then there's also the question of hydrogen for Carlo, and of course the competition with China. Maybe Jürgen, you can also give some views. How do you think like competition with China as a large European motor manufacturer? I mean, there are a lot of consensus that there's not much of the expertise here in Europe. Is this true to an extent? I mean, I would be happy to hear your views afterwards, but maybe we start with Milan to take on some of the questions.
Thank you very much. Thank you for kind questions and to the point. Actually, we call them benchmarks, not targets. And they are, at the moment, they are proposed for the sum of the materials, not individual. You said that they are ambitious. The Parliament and the Council thinks that they are not ambitious enough, but they were based on the criticality assessment, so it does not come from nowhere. We need to realize, for example, in the criticality assessment, we screen the end-of-life recycling rates, input rates. So how much of the secondary raw material enters into the production, or how much it replaces the primary, and usually it's close to zero. So going to 15%, it's a huge jump for many of the materials, and in such a short time, it's extremely ambitious. But still, it may not sound like that. 40% for processing. In some cases, we have no processing at all of some materials. We have magnesium, strategic and critical. We have no refinery of magnesium in Europe. We actually don't have a refinery in the EU of the rare metals. So we have the closest one is in the UK, and is extremely small scale. Okay, so which also brings me a little bit around if there was a question if there is enough space for competition here. Just to realize, we produce around 500 kilo tons of rare earth products or magnets. In the EU, we consume 20,000. So 500 against 20,000. You can build a lot of factories in the EU, okay, across the EU, and each factory is, we talk about in the range of 1,000 tons or whatever, so we can have really many. And how these benchmarks have been derived, criticality assessment and the foresight study at the beginning, so that's where it came from, and also internal consultations, political decision, that's how it has been proposed. Regarding funding, on sovereignty fund, I'm not allowed to tell you much because that's something which is now at the highest levels, and I hope in the coming weeks you will hear the news. We hope that critical raw materials, has been already announced long time ago by a few commissioners before, will be in the envelope. But in which format and whatever, this is really a very, very tough discussion at the moment. So sorry for that. Yeah. Okay. And then the question for if we can have the which countries are there? Actually, definitely my colleagues would be probably more more informed about what's going on the ground. I just can see that over the last 15 years funding different projects, actually SUSMAC Pro and others are our projects from our funding, and we see that practically these are always the same countries, the same club coming. So it's not like that you would have too many hubs. But what is very interesting that it usually there is a potential when there is research capacity and when there is strong metallurgy industry around, or there is a big demand at the spot. So that's something where I would see the biggest opportunities, but it can be in many countries.
Very good. Carlo, yeah.
Well, I can understand that you cannot mention particular countries. I mean, we see a lot of going on in Slovenia. Slovenia is traditionally a very strong country for magnets, even being a small country. But yeah, not metals. Yeah, but in France there are a lot of activities, and in Germany there's some activities. I mean, we at the university, we just created a spin-off, and we are one of the producers that want to produce 1,000 tons somewhere, starting with 150, which is ambitious. And I agree completely that this 15% target in 2030 is very ambitious, but it brings things into rolling because on the other hand, I'm a bit afraid that we will face a situation that we don't have enough scrap magnets that are already accessible to do this, which probably will kill the prices on that side with the recyclers, because they can demand anything and then there's no business case anymore. So that's something to avoid with this target. So I mean, we have to monitor that very carefully. Then coming to the question of hydrogen, yes, hydrogen is scarce, it's expensive, but the process needs very little. And it's, well, in theory, we don't do that now on the pilot lines. I mean, in the pilot lines, we introduce the hydrogen, and in the end, we degas it again, and it goes into the atmosphere, but you can make a closed loop out of it. And on the commercial reasons, once we're in production, that's definitely what's needed, because the hydrogen is stored in the material. And you could use rare earths also as hydrogen storage material. So once it comes out of the structure, it's still the same purity. So it can go in a closed loop, and that's what we have to do. And anyway, in this big hydrogen scenario that's built now, we would be a very, very little consumer of hydrogen overall for the magnets.
Jürgen, any views on competition with China? And more broadly, I mean, are we investing enough in Europe also on motor manufacture? Are we keeping the innovation here? Are you concerned that we might lose some of it from your perspective of a large European motor manufacturer? Yeah.
Sorry, I'm not sure whether I understood your question correctly. We are currently have two fields of activity. The first, I explained, we are working on preparing our products for product cycles so that we can remove the magnets, but not only the magnets, because we have also other valuable materials, for example, aluminum enclosures, which contains a lot of energy, and we have a foundry in France, so we can also use the aluminum enclosures. So we are preparing ourselves and the products for the product cycles. And the second thing are the business models in order to get back the materials. This is our big problem because, as I explained, we do not have the direct access, and we have to make it attractive that our customers give back the old products at the end of their life to our professional dismantler, because we have a lot of service centers in Germany and in other European countries, and also in the overseas countries, which are professionally dismantle the products. And currently we install these processes in Bruchsal, where we have the headquarter, and we plan to roll out it to the Strive Technology Center in Europe and in Germany. We also have international circular process network of colleagues in other companies in order to inform them about our activities, to learn from them, because they also made their first steps, as I explained, our Dutch colleagues, which are very successful with their model of an additional warranty year. And so we are all together in order to bring the things forward.
Very good. Do you want to add something, Spomenka, or no? No. Okay. Okay, very good. Any further questions? Something that is not... Okay. Yes?
Yeah, so again, from University of Amsterdam, when you were doing the presentation, I kind of saw a paradox that in one sense, we kind of want the product to last long because it's a good thing that we don't have a obsolescence programmed, like I don't know the name in English. But on the other side, we kind of need those to be in waste so we can reintroduce them and recycle them. So how do you address this kind of paradox of like needing waste, but also wanting the product to last long?
This is a question in general for many product groups, but yeah, I don't know if you want to take it, Carlo. Yeah.
I think, first of all, we cannot influence it. I mean, what we're currently doing, we're looking at interesting scrap sources. And I mean, we're talking about a 200-gram target here. This may not be the case in all of the products. One example, for example, is hard disk drives. I mean, if you do a study, end-of-life customer hard disk drives are disappearing because you have solid-state drives, but in the server farms on the other side, they're increasing massively. There are only 20 grams of magnets in, but these hard disk drives are shredded today. And when you shred them, the magnet breaks into pieces, it blocks the shredders, so from that point of view, it's not good because they have downtimes. On the other hand, we developed in a Susmac Pro a process where you can chop off just the edge. It's a very crude process if you look at it, just chop off the edge, take the magnet with that edge and put that into this hydrogen processing and shred the rest of the hard disk drive. And because there are millions of them and they have to be destroyed every 2 or 3 years just for data protection, that's, for example, a good business case where the material is available right now. Another source that's interesting currently is the flat screens. We didn't think of that about 10 years ago, and my first television lasted for 29 years. The second one, flat screen, lasted for 3. And so the lifetime in this case is down and they're disassembled anyway. So that's currently a good business case. We looked with a Dutch company that's doing the recycling into loudspeakers. And we found out that in 2 tons of loudspeakers, there are 200 grams of neodymium iron boron currently because they're lasting very long. So no business case. But if you look into an Alexa, and Alexa has nearly 80 grams of magnets, they're lasting not very long. So these waste streams, they have to be monitored and they have to be developed. And In that case, you just have to filter out, and some of the countries are really good in separating the waste. Others, I'm living in one of them, are not so good in separating, even if they tell everybody. So these waste streams also have to be developed. But on the other side, what is something that we learned the hard way is that there are a lot of regulations. So for example, as I said, we're making a spin-off that will do recycling of magnets. But if we would do some of the disassembly, we would be classified as a recycler, which requires all kinds of licenses, which are very complicated. So this value stream has to be developed, and there are recyclers in Europe that are specified on stainless steel, on copper, on aluminum, and so on. And it's our role to teach them what is interesting, what are the waste streams, and also in some cases, because we developed in the projects also automated disassembly units, to transfer this know-how to them. Because if you look, for example, in the model of traction motors, you have to separate the stator and the rotor. Then one idea could be send the rotor to us and we do the rest of the disassembly. But it's still magnetized. You put it in a box, you cannot disassemble them because they're very high forces. So it has to be done at that place that is separating the stator, which is the copper and the aluminum, from the rotor. If they're doing it, that's fine, but the magnets producer just needs the recycled magnet. So the extraction has to happen before. And for a lot of materials, this is developed. For the magnets, it's not. So that's currently where we are in transition, having a lot of talks. But again, as the market is not yet developed, and the interesting quantities like the wind turbines and the traction motors are 15 years in the future, in that case, these recyclers need some incentives, which is funding money in projects, which is fine, but also when it comes to investment, we need some investment here. If other companies like SEW are doing that on their own premises and with their own resources, and this closed loop anyway is the best thing if somebody has access to the end material. But in a lot of cases this is not the case, and the material is just disappearing, distributed somewhere. And so this whole recycling infrastructure needs to be developed, and that's a very interesting subject which goes far beyond that recycling of the magnets where we started.
Very good. I think it will be good to enter a little bit of discussion on standardization. And Carlo, maybe you can start. There's a lot of discussion about what standards exist out there, and it will be very interesting to know what standards exist for rare earth in general. Where do they come from? I mean, whether there's scope for Europe to develop these standards in the future, or maybe cooperate with other partners, also China that has these approaches in place for quite some time. That will be, and interesting to hear your views. Milan, I don't know if you want to comment afterwards on standardization, if it's too specific in your case as well. And Jürgen, I mean, you mentioned that you do the dismantling of the motors sometimes to extract the magnets. I'm wondering whether you see any need to standardize this process, or maybe it's not necessary. Any thoughts you might have on standardization in this regard? Carlo or Spomenka, I mean, you can also, yeah. Good, please, yeah.
Well, referring to standards, that's indeed a very interesting subject, because we've seen that in the ISO committee, all non-ferrous metals, all the conveners, which means all the organization, is done by China. So they basically, and well, that's a very open process. You need somebody that's heading such a committee, but China has done this very systematically. And so currently the ISO committee is dominated by China, and the ISO committee is also developing standards on recycling, on sustainability, and marking and labeling. And it's very important that we European, that we raise our voice here and participate. And we formed now a couple of months ago a German mirror group just to see what's going on, which is the first place. And we found there's one standard about measuring, for example, chemical composition, which makes very much sense. It's a good standard, so no objections here in taking that as a European standard. But I'm a bit worried if China does have the lead on sustainability. And so what the the European CEN with the German initiative is now doing. We just demanded to have a European CEN committee on standardizing rare earths. Of 33 member countries, 21 voted in favor, but only 4 voted to participate. And until tomorrow, we need a 5th country to participate, to tick that box. Otherwise, it will not be granted. So we're in the middle of that process. But I think also on the standardization side, because that's also a very strong tooling in influencing things, we need to have a European voice here.
Actually, if I can jump on that. Carlo, can we speak about it just after?
Yeah, sure.
Okay.
That's what my teacher said sometimes. That never ended good if he said, I have to talk to you.
For us, it's a very important thing because we noticed with this standardization, the technical committee 298 for rare earths, that was a first really big example when China took the secretariat and very systematically started to copy Chinese standards into international arena. And we realized that there were no EU members of the committee. There were some observers, but no members. So actually, all this area went outside of the radar of the EU industry. And surprising to us, when we were checking with certain countries, and because standards in the countries are practically controlled by industry, none of the EU member states were interested at the beginning. Then we tried to explain what does it mean and which industries are targeted. Immediately received response from several countries. I will not mention which ones, but probably that's the 4 ones or 4 or 5. So that's the situation. Interesting enough, we noticed immediately after that China launched another committee on lithium, TC333, but there Europeans have already been prepared. So of course, now there are several other attempts to cover different parts related to the strategic technologies and especially for green transition. So renewable energies, e-mobility. So that's where we really would like to ask member states, the standardization organizations, the industry, to be very, very active. Otherwise, we are losing grounds. And then sustainability. Carlo, you mentioned that if sustainability is led by somebody like China, the point is that in some cases this is not even discussed. Okay, so it's not the question who leads, but these aspects are put aside, and that's where we have a problem.
Yes, of course. I mean, when you're leading a secretary, you can guide things a little bit, and there's also a discussion about marking. But it's obvious, for example, that the Chinese magnets manufacturer doesn't necessarily have the ambition to mark something that it can be recycled in Europe, and that's perfectly fine because I mean there are industrial interests behind it, and no hard feelings here. But on the other side, we have also needs and requirements that have to be heard, and we have to write them into the standards. Otherwise, we lose here. And yeah, so hopefully we find that 5th country. We just have to tick a box, and so yeah.
Jürgen, any thoughts on standardization from your perspective? Do you have something to add?
Yes, from my point of view, I'm also a little bit skeptical that China will follow that way and will give information on the content and the amount of material, because usually when we order magnet material, we only define the magnetic properties and not the constituents. This is the business secret of the manufacturer, and I'm not convinced that these companies are willing to present their information.
Very good.
Just to add here, that's a very interesting and important point. In any other material, you buy a chemical composition that's related to some mechanical or chemical requirements. So if you order stainless steel, you know the exact chemical composition. But in magnets, you order a magnet grade, which is a performance, and it could be done in a lot of different chemical compositions. And here, this business is ticking completely different than any other materials industry, which is quite surprising. And this is something where standardization probably could make a turnaround, which could be in favor of a European industry.
That's what we propose in the act, actually, in the label.
Yes, please.
Thank you. About these standardization committees, are there already ones for tantalum, tungsten, and conflict, which are known conflict minerals?
I mean, yeah.
There is a new initiative, but I'm not aware of precisely on these materials, because the standards are, ISO standards are meant for industry. Okay, this is not it's not a political forum. Okay, so that's a bit different.
I think there's a sustainable mining initiative. There's one standard that's used for mining, but it's not like there is a discussion right now on standards specifically on the primary sourcing, but on recycling is a different question because it has to do with the industry, as you mentioned. But let's say it's a complex and evolving landscape. I would say, I mean, I don't know the very details, but a lot of people now have been discussing about whether we have the right standards in place for mining. And there is a particular initiative that people praise that is a good one that goes up to the ground. I forget the name. I think it's called Sustainable Mining Initiative. For recycling, yes. But I think this has been answered. Yeah. Okay. Good. Any further questions? Or yeah.
Yeah, I'm Tobias. I'm writing my master thesis also about dismantling and electric motors. And my question will be, if you find incentives, which will be probably a big hurdle for the customers, will the future be an automated dismantling or manual, or will it be like a hybrid process for electric motors or other products containing rare earth magnets?
Yes, that's a good question. Thank you. I think the end of the road will be a fully automated process because we have to reduce the cost for dismantling as much as possible. And if you do that manually, it will not work competitively. So we cannot cannot allow that the costs are too high. So our products with the reused magnets would be also not competitive in the market. So we try to go that way, but we are starting with small steps. Primarily, we have to get back the material. We have to professionally dismantle it. We have to sort it. Aluminum goes to the aluminum recycling industry. Magnets go to Carlo Burkhardt's facilities, which will arise. And so on. It will go step by step. And at the moment, we have too less backflow from old motors that that it would make sense to have the invest in a fully automated system. And also, we have the problem. My company is manufacturing millions of variations of the products because we can arrange gears and motors and electronics. So to find a fully automatic system would be very expensive, and that's a major problem at the moment. But we are going that way.
And we're looking at the same thing for traction motors. And here, surprisingly, with the current electric cars that are on the market, there's a huge variety in the arrangement of the motor. If you look into internal combustion engines, they look all similar. So that means it's not fully developed, the whole thing, and it will get a lot of changes in the future. So what we try to build now is a kind of multi-purpose system, pressing out the shaft, separating the magnets from the electrode sheet, and Laura, who's sitting there, she's writing a PhD on that, on a design for recycling, together with a major tier 1 that's doing electric motors. And there's some challenges but it's the only way, because the labor costs in Europe are far too high to make that a business case by manual dismantling. And for the larger 200 grams containing things, it's also a safety aspect, because these magnets are very complicated to mount if they're magnetized. So a lot of manufacturers mount it before magnetizing and then go on with a special coil. But you don't have that option when you're recycling. So you either have to do a thermal demagnetization, which is not good for the environment because you burn the glue and everything. So that's a kind of trade-off, how you press them out, but it can only be fully automized. And that means huge investments, and it's a bit of a vicious circle because the OEMs say, how much is a kilogram of recycled magnet out of my traction motor? And then we can estimate, oh, this takes 6 seconds or 8 seconds or whatever, and these estimations are always wrong. Most of the time they're far too ambitious, sometimes the other way around, that doesn't happen too often. But you know, to get the business case attractive, you have to have these test benches. And here again, we're depending on funding money, because for some reason the large OEMs, they have very large ambitions and requirements, but when it comes to funding something, they are not that keen anymore, unfortunately.
If I may, a question for you as a representative of Europe. Are there any chances that Europe could help with regulations or kind of support in the way that magnet producers would buy the recycled materials? Because we just learned yesterday during our project meeting that the prices of rare earths are dropping, and this happened already some 10 years ago when Europe and the whole world started to invest in research in rare earths magnets. Chinese, from this crisis, the prices dropped significantly, and this is happening again. So if the prices of raw material from China will be so much lower than the price of our, let's say, our recycled material, how can we convince the producer of magnets? Is it possible that we do this with some regulations, or it's a stupid question?
No, it's a very practical question. Thank you very much for that. Actually, you see the same manipulation of prices on the market as we've seen in 2011. Now we had in 2022, we had a peak, huge peak. Now it goes down again. So it's a cyclic thing. There is no real reason behind what is, there is no increase in production costs or whatever. It's just manipulation on the market. That's why we try to act a little bit differently. That's why we try to step up. Action Plan 2020 was not enough. We go for regulation now. And now you're asking how we motivate recyclers or the magnet producers to buy. So it's the Article 28, which I showed, is the recycled content. At the moment, we will just see how much of the recycled content is there. After 2030, we would be allowed to do the minimum recycled content requirement. Okay, it's not something which is compulsory, but this is something which may happen. That's the Commission. That's what is in the discussion in the Council and the Parliament. Which, by the way, I did not mention at the beginning. They work extremely hard to get this regulation at least done. So we see that Swedish presidency is doing amazing job. So it's unbelievable how fast they are. And then on the Parliament side, also the discussions are very fast. So definitely completely different schedule than from battery regulation, which is already there for. No. It's It's over 2 years. It's well over 2 years, but this one is really much faster. So, and not to mention that we took inspiration from battery regulations. So also on recycled content and labeling.
Thank you very much.
No, I mean the process. Yeah.
Sorry, just one small remark. In 2019, before COVID, we had a meeting in Torino where Roland Gauss was having such a panel, and we were discussing how to come to the situation with the batteries. They are so successful in what they do, and it is only 4 years now, and we are getting very successful. Thank you.
It's the same, yes. Thank you very much.
Yuri, you wanted to comment? Or no? Okay, there's one question here in the back. Yeah.
Eduardo Righetti from SEPS. So if time allows, I will just ask one very quick questions. On one point to Mr. Grohold. So one point mentioned earlier was that, if I understood correctly, on top of the very targeted and specific provisions on magnets within the Critical Materials Act, there will be other provisions on magnets in other pieces of legislation. So other provisions will find their way in other pieces of legislation. You mentioned, if I'm not mistaken, the ELV directive. So could you please maybe elaborate a bit on this? What could we expect on this front? Which kind of provisions in which pieces of legislation? Thanks.
Yeah. Okay, and after Milan, you give these points. Maybe I give the floor to everyone if you can identify any key messages or takeaways or priorities in 1 minute each of you for the coming months and years, and then we can close and go for a nice lunch. Yeah, Milan.
I deeply apologize. This is something which my colleague Maria Nyberg is working very hard just now. Actually, she will have a meeting in the afternoon, but I can come back on that later. But what can I say about that? But just to confirm, we are working on all legislations which are in the waste legislation, which are in revision already. So you can bet that magnets will be at least discussed, if not included.
Very good. But I think it's already mentioned in the proposal that there is this effort to really align requirements in different pieces of law and achieve coherence as much as possible.
There's an article on coherence. Yeah, on that. Perfect.
Good. I don't know who wants to go first for any key takeaways or messages or the way forward in 1 minute. Something that you think, or you might think that things are really in the right direction and there's no key action that is needed for the coming, let's say, months. Who wants to go first? Carlo, you're good with these things, No,
it's me. Okay. I think a lot of bits are falling to place right now. I remember in the old days, we were working on neodymium iron boron because iron was cheap, boron was cheap, neodymium was something nobody needed, and we said there's no cheaper magnet on the world than neodymium iron boron, and it was an answer on samarium cobalt. Now we have this situation and we react to it, and I think a lot of things are falling into place, as I said. I'm a bit worried that our friends on the other side of the Atlantic, the Americans, are much faster than we are right now. I know this is one country, but we see they're investing massively. They're coming out with subsidies in this Anti-Inflation Act. And we see now that some of our experts going to the US because things are happening there and they're also actively approached. And that's, of course, another thing. And for me as an academic, also one that's not very satisfying one. And you said you don't understand completely how we're doing the recycling. That's exactly the same for material scientists because we don't have magnets experts. Magnets are not happening. They're a little bit in physics, a little bit in chemistry, a little bit in material science. But when it comes to neodymium iron boron, we don't have any experts in Europe. And in China, 2,500 engineers every year finish only specialized on this. And this is not fair. It's like a football world championship in a small country and the big ones are competing. Here with a clear outcome, of course. But that's something we need to do as well. We have to bring this technology again into the market, also to the end users, what magnets are, also to our young people, not only to have the user side of it, but also what's behind it. I'm struggling with my own kids on that. But that's something I mean we have to do to really develop the magnets expert and to bring this subject really into the educational system. So these are my points.
Spomenka, yeah.
I will repeat what I said before. I'm happy to be still involved in this field at this moment because we were struggling so many years, and all my professional life I work on rare earth magnets, and as I said before, this is the golden era. Okay, Carlo said Americans are faster. Maybe they started faster like they started faster in 2011. But Europe is following very fast. And I think with the so many experts in, our generation, but we are teaching the young ones as well. In Europe, we can follow up quickly. You know, in Texas, there was a huge amount of money invested for the recycling plant. I'm not sure if this is still working or not, but we are in the moment here, and I believe in this moment, and I'm grateful. Thank you.
Okay, I think I will close the session. Yes, I'm very happy that we have the support from the European Union and all these new activities concerning the raw earth and the critical materials. And I'm also happy that we are on a scientific state, that we are able to realize these recycling facilities in the near future. However, we have to accelerate, as Carlo Burkhardt said, because only the fast one will be successful, and we have a chance, and we have to cooperate all together in order to reach that common goal. It's a common goal for the whole continent.
Thank you, Jürgen. I would like to take the opportunity to thank all of the excellent panelists and Adrian for your contributions. Thank you, really. This was a great discussion. Thank all of you for coming today. Maybe when you go back at home, maybe you can look into the appliances to see where the magnets are, pretty much in a wide range of appliances. So now, yeah, we are very pleased to have done this event, and hopefully we can do more of this from autumn onwards. And yeah, please join us in the green room downstairs for a buffet lunch and also for a networking opportunity. Thank you.